Morning to all of you. So today we are going to discuss the chapter is application of integrals, and this is a very interesting chapter from mathematics. This you are going to study in your 12th class also, and apart from that, if you go for higher studies there also, like in engineering or in any other branch where you study higher mathematics, you will be definitely studying this, and this comes under the application of integrals. So we are starting with this application of integral. There are so many applications of integrals, like we have the calculation of area of a area bound by a curve, either with a line or area enclosed within two curves. Between two curves there can be more than two curves and so on. We have to find the area enclosed either by a curve or one or two lines, or area enclosed within by the different types of curves. So you should also know for this purpose what are the different types of curves. Like generally we come across parabola, we come across a circle, we come across an ellipse, or we come across the sine curve, cosine curve, that is the trigonometric curves for the purpose of calculation of area. Then we have the plot of exponential curve, y equal to e to the power x, y equal to a to the power x, and then we have the curve like y equal to log x, and other different types of functions which come across when you go for the exams, like you have JEE or any other type of exam. So one thing I would like to assure you here, that this is a very simple type of the problems which we are going to solve here. Very simple, but only if you are clear with the fundamentals. So fundamental or basics of this chapter must be very clear to you. One thing is that you should know how to plot a curve. That we have discussed separately, how to plot a curve, plotting different types of curves. Then you should be very clear with the fundamentals of integration that we have also discussed. So these things will be very helpful to you, and I assure you 100% that it will be very easy when you solve this problem in the exam, whether it is any type of exam, whether it is boards or JEE or higher mathematics. So let us first discuss the area enclosed by the curves in this chapter. So first of all you should know the concept. Suppose we have a curve y is equal to fx, means y is a function of x here. That means we have to input the value of x, so independent variable. This is depending upon x, so this is dependent variable. So suppose the graph of this is like this. This is the graph of y is equal to f. Enclosed between this curve and the x-axis. This is our x-axis and this is our y-axis. From a point, starting from this point to this point, you can take any point. Suppose I have here x equal to a, and here we have x equal to b. So the first thing is that the function should be continuous in the interval in which you have to find the area enclosed. So here the interval is a to b. So function should be continuous within these points. So let us assume that the function is continuous. Now what to do? So area, general definition of area, if you take a rectangle, what is the area of the rectangle? Area is equal to length into breadth. This is a rectangle, so this is height h, and the base, the breadth, suppose this be equal to c. So area is equal to c into h. So now what is the purpose of introducing this rectangle here, area of a rectangle? The purpose is that this area enclosed by the curve can be divided into such small rectangles. Suppose if I take this rectangle, so if you find the area of this rectangle, then what is that area equal to? That area is equal to, suppose this distance from the x-axis, this is x, and width of this is equal to dx. And what is the value of y here? At this point or at this point, there is not much difference in the height of the curve. So actually, this rectangle looks like this. That means this point and this point, this gap is very small, can be neglected, and this can be approximated as a rectangle. Although this is exactly not a rectangle, but we can approximate this to be a rectangle. So what is the breadth or base is dx, and height of this h is equal to y coordinate. This is x, this is y, this is xy, this is x plus dx, y plus dy. So dx and dy are very small. The coordinate of this point are x and y, and this is x plus dx and y plus dy. So this is x, this is dx, so x plus dx, and this is y plus dy. This side is dy. So dx and dy are very small, both are tending towards 0. So what is the area? So area of this small rectangle dA is equal to y into dx. So this is the area. So you can approximate that the curve is made up of small rectangles, large number of rectangles. If you decrease the width, dx is very small, tending towards 0. Okay, this height is dy, this is dy, this is also very small. So this is now exactly a rectangle. If you have large number of such rectangles such that the thickness is very small, so the total area enclosed within this is given by integral of this, assuming that the function is continuous. There is no gap and the function is continuous, it is given. So what is the variable here? So y can be put here in terms of x, y is equal to fx. So we have only one variable x. And how is x varying? X is equal to a at this point to x is equal to b at the other end. So x equal to a to x equal to b. So this is how you can find, you can evaluate the area. Now if the function is given in this form, y is a function of x, like y is equal to x, y is equal to x square, y equal to x cube, y equal to sin x, y equal to log x, y equal to exponential x, etc. In this case you will be using this concept. Suppose it is given that the graph of the function is in the other form, x is a function of y, and the graph is like this. So here what you will do, you will be taking a strip or a rectangle which is parallel to the x-axis and perpendicular to the y-axis. Suppose here I have y is given as y equal to e, and here at this point y is equal to f. Then what we will do, let us take the rectangle like this and find its area. So this distance from the x-axis is y and its thickness is dy. So dA is x dy. So you will put x as a function of y because x equal to fy is the equation of the curve. So total area is given by integral of dA, that is integral of x dy, where y is varying from the given value e to f. So these are the two ways, and you will select the way according to the question which is given, so that we have to find the area of the curve. Now some questions in which the equation of the curve which is symmetric, x square plus y square equal to a square, that is the equation of a circle. We can use both the methods. You can calculate the area by using any of these two methods and you will be getting the same answer. So this is how to find the area enclosed. Now let us take a question based on this so that we are familiarized with the concept. So the first question is, you have to find the area enclosed by x square plus y square equal to a square. So friends, first of all, you should be very clear with the concept that what type of curve it is which is given here, for which you have to find the enclosed area. Clearly this is a circle. And just for making you remind, the equation ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. If you remember this equation, what does it represent? If we have h equal to 0 and a is equal to b, either both of them are 1, or if not equal to 1, at least they are equal, so that we can divide the whole equation by a or b. In that case, this represents a circle. And you can see here a is 1, b is 1, h is 0, and this constant is equal to a square. So this is a circle with center 0 0 and radius is equal to a. X square plus y square equal to a square. So we have to find, first of all, we have to plot the curve. These are our axes, the origin, and now let us plot a circle. Not very difficult, this is very easy. The radius is a, so this is our circle. So what are these points? This point is a, coordinates are a0, b 0a, c minus a0, and d 0 minus a. O is origin, center of the curve 0 0. So what is the total area enclosed? 1 2 3 4, 4 similar types of quadrants. So if you find any of these quadrants area and make it equal to 4 times, then you will be able to find the area enclosed by this curve. So what we have to do, we have to find the area of this curve, means area of OBA. OB means this quadrant, any of these quadrants you can find the area. So why we are doing this? Because this is symmetrical in all the 4 quadrants. So let us take a small elementary strip in the form of rectangle here. It is at a distance x and thickness is dx. So the area enclosed is 4 times of area OA, let this point be E, OA EB, OA EBO, because this is a closed area. Now we have to find area OA EBO. This is equal to integral of y dx. Y is a function of x. What y is equal to? From this equation we can write that y is a square minus x square under root. Now we have here 2 values of y, plus and minus. Which value of y has to be taken, plus or minus? Now this depends upon your jurisdiction. See, y is positive in this direction and negative in this direction. If you take y both plus and minus, means you are finding the area of this semicircle. and then the strip will be extended in this direction up to here. Now we are taking the area of this first quadrant only, so y here is positive. So we have to take plus value of y, neglect the negative value. So this area is under root of a square minus x square dx. Now x is the variable. How x is varying? X is varying from this point to this point. Here x is 0, here x is equal to a. So 0 to a. Okay. And a is equal to, means this area is 4 times of this. This is not OABO, this is total area. So let me mark this arrow. So this integral you have to evaluate and then you will get the result. And you know that by substitution you can use the standard formula, and here if you are using substitution, x is equal to a sin theta or a cos theta. This we have discussed separately. So on evaluation, this gives us 4 times of x by 2 under root of a square minus x square. I am writing the standard result because this has been discussed separately, plus a square by 2 sin inverse x by a. And the limits are 0 to a. So now put the values. So if you put x equal to a, this term becomes 0. So if you put x equal to 0, this term becomes 0. So this is 0. When you put x equal to a here, sin inverse a by a, sin inverse 1 minus sin inverse 0, which is 0. So 4 into a square by 2 sin inverse 1 is pi by 2, which is equal to pi a square. This is the answer to this question, pi into a square, which is the area of the circle. Now if you take a horizontal strip, in this case, what you will do here, in place of x, it will be root of a square minus y square. If you take a horizontal strip, then x dy, x is root a square minus y square dy, 4 times of this, and the y is varying from say this point to this point, 0 to a. You will get the same result. The only thing is that here in place of x you will get y, but the value of y is same, so you will be getting the same result, pi a square, if you take a horizontal strip. Then you will get the same answer. So this is how you can find the area enclosed by a circle. Now next to this, we have to find the area enclosed by an ellipse. So obviously this is an ellipse where major axis equal to 2a and minor axis equal to 2b, and center is 0 0. So first of all, let me draw the curve. This is the major axis, and the minor axis. A0 minus a 0, 0 b, 0 minus b. O is the origin. This point is A, B, C, D. Now the concept remains same because this is also symmetrical in all the 4 quadrants, just like a circle. Now one thing should be very clear to you, that this circle which is having radius r, if I apply a force in this direction such that this circle is converted into an ellipse, so one of its axis is extended and another is reduced. This is A and this minor axis is B. Radius of the circle is r. So one thing you should remember, and this can be proved, that r is equal to under root of AB. This is a very important result which sometimes is very useful while solving the problems given in any entrance exam. Radius of a circle is equal to the geometric mean of the major and minor axis, semi-major and minor axis of an ellipse, provided both have same center. So let us take an elementary strip here. Again you can take this strip horizontal also, vertical also, and it is at a distance x from the center and having breadth equal to dx. The height of this is equal to y. This point or this point, they have very small difference in their heights, or the value of y is same. So the area of this will be 4 times area A enclosed is 4 times into area OA BO, means area of 1 quadrant of this ellipse. So this is 4 times y dx equal to, putting the value of y from here, you can put y a by b under root, sorry, b by a of a square minus x square. Again this is having plus minus values. Which of this you will select? Y is positive here, so we are selecting the positive value. So put the value of y here, b by a under root of a square minus x square dx, and y is varying from x is varying from, x is the variable, 0 to a. This is the area enclosed by this curve within the first quadrant, and that is multiplied by 4, so this gives the total area. Because now here you should note one thing, this is a symmetrical curve in all the 4 quadrants, so the area enclosed by each quadrant is same. That's why again we have multiplied this by 4, otherwise you cannot multiply by 4. If it is symmetrical in 2 quadrants, then you can multiply this by 2. So again this is a standard integral. B by a is a constant, can be taken out. So this is a standard integral as was in the previous case. X by 2 root a square minus x square plus a square divided by 2 sine inverse x by a, and 0 to a is the limit. So 4 b by a. If you put x equal to a here, this will be 0, and x equal to 0, this is 0, so this is 0, plus a square by 2 sine inverse 1 a by a minus 0. Sine inverse 0 is 0. So 4b by a into a square by 2, sine inverse 1 is pi by 2. So the area, this whole area is equal to pi AB. Pi AB is the area enclosed by this ellipse. Now if you compare this with area of a circle with same center, as I have discussed there, same center is equal to pi r square. If you compare them, you will get r is equal to root of AB. Means when you applied a force like this, you can understand this. Take a bangle made of a metal, put it in a vertical position, apply the force in the vertical direction downward. So one diameter will increase, other will decrease. So the initial radius is the geometric mean of the two radii. So this is how you can find the area enclosed within an or by an ellipse. Now after this, we have to solve the next question. We have to find the area enclosed by a curve and a line. So question is, find the area enclosed by y equal to x square and y equal to 4. So this, you know, obviously is a parabola. So first of all, let us draw the curve. The first point you should do while you solve these problems is draw the curve first. So which type of parabola it is? X square equal to y, positive. So this is a cup shape parabola with vertex 0, 0, and the axis of the parabola is the y-axis. So this is y is equal to x square, and second we have y equal to 4. So what is its focus? The focus, in case you want to calculate find the focus, then y x square, the standard equation of the parabola is x square is 4ay. So if you compare, 4a is equal to 1, a is 1 by 4. So its focus is 0a, 0, 1 by 4, 0, 1 by 4, this is the focus. Now y equal to 4, 1, 2, 3, 4. This is the straight line. Y equal to 4. And they are intersecting at 2 points. So this total area enclosed you have to find. This point is O origin. Now suppose this point is A, this is B. You have to find the coordinates of points A and B. For this you have to solve these two equations, y equal to x square, y equal to 4. So x square equal to 4. If I put y equal to 4 here, that gives x is plus minus 2 and y is equal to 4. So the coordinates are A is 2 and 4 and B is minus 2 and 4. This is 2, 4. This is 2 and this is minus 2 and this is minus 2 and 4. Now you can see this curve is symmetrical about which axis? symmetrical about y-axis. So the easier method of finding the area of this is take a strip which is horizontal, means parallel to the x-axis. So you find this area in the first quadrant, let this point be D, O, A, D, O, and make twice of it, so it will be total area enclosed. So which area you will be getting then? I will shade this area, double of this area, this whole area. Or if you extend this strip in this direction also up to this point, then the value of x will be varying. Where to where? -2 to 2. Otherwise 0 to 2. X dy we have to take. And then you can find the area enclosed. Another method of doing this is, let me show you. I am taking the first quadrant shape of this parabola only. This is 2, 4. This is 0, 0. Now if I take this strip in this direction, now what is the area we have to find? You have to find this area. O, this point is A, this point is D, suppose this point is E. So area O A E O is equal to area of the rectangle O D A E minus area O A D. Sorry, you have to find O A D O. Okay, O A D O, not A O, minus area O E A O. This total area minus this shaded area, you will get this area. So what about this? This area, this is the rectangle, where this dimension is 2, this is 4. So 2 into 4. What about this area? This you can find by the area enclosed between this parabola and x-axis and this line x equal to 2. If you subtract this, you will get the same result. Now let us see by using both the methods. So by the conventional method, area O A D B O is twice of x dy. I have to write. So putting the value, y is equal to x square. So x is plus minus root y. You have to take positive value of y. So root y dy. Y is the variable. And how is y varying? At this point y is 0. At this point y is equal to 4. 0 to 4. So if we evaluate this integral, so 2 and using y to the power n dy is equal to y n plus 1 upon n plus 1. Y to the power 1 by 2, n is 1 by 2. So y to the power 1 by 2 plus 1, so this is 4 by 3, and 4 to the power 3 by 2 minus 0. So this gives us 4 by 3, 2 to the power 2 into 3 by 2, 2 cancels out. So 32 by 3 square units. So this is the answer which we are getting by using this method. Now let us do this by the other method also, so that is also clarified to you. Now this area, as per this written statement, you can see this. What is area ODAE? So I am writing the total area, double of ODE. Either you can write this as area equal to area of a rectangle. You can see in that figure ODAE. This point I have taken as E. Or we can also write this as, if you take a vertical strip y dx, y1 dx. What is y1? Y1 is the upper curve. This is the upper curve. What is this? Equation is y equal to 4. And what is variable here? X is the variable. Minus the area enclosed by the lower curve with this. So y2 as per this equation. This upper curve, which is a straight line, 4 dx. X is varying from 0 to 2 minus y2. Y is x square, so x square for this lower curve, parabola, dx. X is varying from 0 to 2. So calculate this. This is 4 into 2, 8 minus 8 by 3. So this is the answer that you will be getting, which is equal to 32 by 3 square units. So either way you will be getting the same answer. So this is how we can solve the questions in which you have to find the area enclosed by a curve and a line or another curve or like that. So rest we will be discussing in the next class.